Good morning, everybody. Here we are with Inventive Code Day 2. Let us get into this and see what the day has to offer. Day 2, Rock, Paper, Scissors. The elves begin to set up camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game played between two players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. Then a winner for that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, which will be our puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, and C for scissors. The second column, suddenly the elf is called away to help with someone's tent. The second column you reason must be what you should play in response. X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. We don't want to look like we're cheating. We might be cheating, but we don't want to look like we're cheating. That's a very good thing right there. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected, plus the score for the outcome of the round. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. What would your total score be if everything goes exactly according to your strategy guide? Alright, so this seems like an interesting challenge right here. I could see us doing some hash maps for points, probably a for loop depending on how big this input is. Oh, yeah. Okay, so we got a lot of input to work with here, but this shouldn't be too difficult, I don't think. Alright, here we are back over in VS Code with a day2.py file ready for us to work in, and we already have all of our input copy-pasted over here. So, let's start working on building some maps real quick. We'll go ahead and define our process. We'll have our process take pairs that we're getting fed. We'll have our pair map right here equal to a dictionary, and we want to map it to what we play, not what they play. That way we can keep track of points too. So if we've got X is for rock, which means that we have to have them play C. C, of course, being for scissors, which also gives us 1 point simply for playing X. So now, if we play X, we can figure out what they need to play for us to win and compare that, and what points we just get for playing that anyway. So let's go ahead and move this down here and do the same for Y and Z as well. Okay, so there we go. Now we've got X, Y, and Z, A, B, and C, 1, 2, and 3 right here to work with, all properly set up, I do believe. So if we play rock and they play scissors, we get 1 point and a win. If we play paper and they play rock, then we get 2 points and a win, etc., etc. So let's go back over here and build our parser for the day, which we just want to go ahead and open up this input2 text file as our file pointer. Okay, we'll go ahead and read in the lines from there. We'll split that at a new line. We'll use a list comprehension to split these lines up, and we'll return that and see what it looks like. Python day2.py. Okay, what do we got wrong here? Oh, whoops. Read lines is already going to be splitting at the new line since it's a read lines, so we can delete that safely and try this again. Okay, that's something we can work with right there. Lots of little pairs stuck together. The first one, of course, being theirs, and the second one being ours. Okay, now we're going to start collecting up our total points. And I think for this, we're going to use a sum of a list comprehension. So we're going to do a for pair in pairs. And then over here is going to be the value that we're working with. X is what we need to find the value for. X is going to be equal to this number for each letter in pair, and the points 1 if we do this or if we draw. So actually, thinking about that, I think we need to have our draw value in here as well. There we go. Now we have our value set aside for what it looks like if we draw. Okay, now I think what we are going to do here is have a secondary list for each of the 3 values. We have our win value, our draw value, and our base value, which we'll do in a little list like this that we are also summing up here, which our first value will be that base value. You know, we might move our base value to the front of this list. Okay, now these are moved to the front of the list here. That makes a little bit more sense. We can calculate that base value first. So to get that base value, we will have the pair map of pair 1 and 0. Now if we print process on a list with just the letter X, we should see 1 returned if we return total points. Let's try this. Well, that's no good right there. Oh, I see what it is. Of course, we forgot to include what they played first. So let's say they played A. And this should be a 2-dimensional list. There we go. Now we're back on track. We've got 1 right there. So that's our first value set up. Let's go ahead and do our second value, which now for our second value, we need to see if we won. So I think for this, we'll use a ternary type operator here. So 6 points if pair map pair 1 is equal to pair 0, else 0. And we still just get 1. But let us say that they had played C instead. We get a key error because we switched ours instead of theirs. There we go. 7. Now we have 1. But instead of winning, let's say we draw. In this case, let's do a second ternary operator that happens after the else. We'll say the same thing as over here, except this time we want to check the last value. So we get 3 points for a draw if that, else 0. So now let's print this process on our parser and see if we get the right value. And we get ourselves 17,189. Let's see how that plays out over in the advent of code. That is the right answer. Congratulations, we are 1 gold star closer to collecting enough start fruit. Let's continue to part 2. And now, what do we got? The elf finishes helping with the tent and sneaks back over to you. I forgot we're cheating with this. Anyways, the second column says how the round needs to end. X means you need to lose. Y means you need to end the round in a draw. And Z means you need to win. Good luck. Oh, this is completely different. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. Well, look at that. We wrote up an entire program for the wrong thing. This is why you should always pay attention to instructions. And while that elf walked off and didn't talk to us, we spent how long building up our own system for the wrong purpose. Oh, well, we can fix this, though. We're a special elf. Alright, so let's rethink this through here with our new, very fancy process 2 and see what we can do instead of that. Okay, let's see how we're going to go about this here. I think that the idea we're going to go with is still going to be mapping the X, Y, and Z values, but we might need to have a second dictionary inside of the first. So right here, the first thing that we can do now is instead of having our base value be the number of points that we get for that letter, we can instead have it be the number of points we get for losing or drawing or winning. Then in our second dictionary, we have the number of points we get depending on what they play this time. So for example, up here, if we need to lose and they play A, which is rock, we need to play scissors, which of course is going to evaluate to 3 points. Then we can simply extrapolate this out for all the values. Now this we can use to build our total points like we did above. Now x is only going to be equal to the value of 2 other values added up this time, so I think we can avoid that sum for the moment. Actually, come to think of it, we could probably get rid of this sum up here and make it a little bit simpler on the eyes. So down here, let us create our first value, which is going to be from the pair map. Of course, we're going to get our base value. Now to this, let us just add the value of whatever this is over here. Okay, let us see here. We have process 2 written out, ready to be called. We're going to be calling it with them playing a value of A and us needing to beat them. So let us go when we look at the map. If we beat them, we get our 6 base points. And if they play A, which is rock, we must play paper and get our secondary value of 2 to add to that. Let us see if this works here. Uh-oh. What we have failed out here is that this value right here is actually this tuple. We did not consider it being a tuple. We thought of it as an int, and as such, it would not be able to be added to our next value here. To fix that, it should be as easy as taking the first element from it with a 0 there. So now let us give this another try, and we get a value of 8. Which, as we saw before, that's 6 for winning and 2 for it being paper. So I believe that was a success, and we should be good to try this on our input. 13,490. Is this value good enough to pass? We shall soon see. Congratulations! Once again, we have the right answer, and we are 1 gold star closer to collecting enough star fruit. We have completed day 2. Woohoo! Now, that was a very exciting day 2, very enjoyable programming session for the morning, and I look forward to doing it again tomorrow. I will have these posted on my GitHub, and we'll have a link in the description to that repository. So if any of y'all are wanting to look at the code, be my guest. Now, as always, if any of y'all enjoyed, please consider giving a like and a comment. Thank y'all so much for watching, and of course, I will see you again tomorrow. Until then, goodbye.